Well, apologies to everyone who was following me on the earlier broadcast. I did not realize that responding to a text would kill my broadcast. So apologies if you were on the earlier broadcast and suddenly things just stopped. So we're back on the moon here. This is now part 2. And when we left the other broadcast, we were talking about a couple of things. One is the Sea of Tranquility here, and its lava flows that are a bit more blue because of a slight difference in composition, a little bit more titanium. You can see a couple of wrinkle ridges here. Wrinkle ridges occur when the lava cools and contracts a little bit, and we get some stresses built up in these lava plains. So we're broadcasting from southern Alberta, northern Vulcan County, southeast of Calgary, Alberta, and we're using an iPhone 11 Pro um, attached to an 8-inch diameter or 20 centimeter diameter Newtonian reflector on a Dobsonian mount, which is a wooden mount which is not tracking, and that's why we see the moon drifting here. That's the Earth's rotation that we're seeing magnified. Those isolated specks of light there are mountaintops that are being illuminated by the sun just beyond the main terminator line. Looks like the wind has died down, so that's always a good thing when you're trying to observe with a telescope with some amount of magnification. This is the south end of the moon. This is an astronomical telescope, and what we've got is a inverted view of the moon. Left and right are also flipped. No UFOs. I've been in this hobby for, let's say, about 40 years. Never seen a UFO. Seen some weird things, but they've always turned out to be things that we understand. Let's go to the northern tip of the moon. Let things drift across. I am going to zoom a bit out. Yeah, I could tell the camera's getting a bit unstable. iPhone 11 Pro is a 3-camera phone. The middle camera likes to work well at lower light levels. And even though it looks like it's bright, the telephoto camera, which gives us the zoomed image, just doesn't seem to work as well on a telescope. So we've got the whole moon in there. The moon's about half a degree across, so my field of view is just slightly larger than that in the up and down, north-south direction. Right. Sorry for that red dot. I've got the drawing tool on while I'm trying to zoom. Well, how could it be a UFO? Well, I guess it was unidentified to you initially, but yeah, obviously a helicopter. No longer unidentified. So let's take a look here. A couple of wrinkle ridges. I'm just going to trace them but they're in that mar, or Latin word for sea, mare. With the low sun angle across the lava plane, those stand out pretty nicely, but they're very low relief. So you don't see them normally unless you get the low angle of sun near the terminator, which is that terminator is this line here, right? The line between night and day on the moon. Once we get further away from the terminator, we have fewer shadows. I'm going to start to point out, but what we see, for example, right there, there's a crater with some rays of finely ground material that's splattered out of the crater. Any of these light blotches here and here are also younger craters that have debris, fresh debris. Terminator on the moon. Yes, somebody write that screenplay. I guess if the Terminator on the moon lands, does he say, I am back, or we'll be back? I'll be back? Hard to say. Someone work on that screenplay for us, though. Terminator on the moon. You can see the image dancing around a little bit. That is variations in density of the atmosphere acting as a lens. Yeah, whoops, wrong place. Yeah. Hopefully you can't hear my one dog barking her head off. She thinks she's defending the acreage against coyotes, but I'm pretty sure there's no coyotes in the near vicinity at the moment. I'm a bit klutzy here with these big heavy gloves I've got on. When I say younger, well, that's a good question, because most of what we see on the moon is pretty old. Like these lava plains, which have few craters on them, formed in the late heavy bombardment era, which is roughly ended, say, 3.8, 3.5 billion years. So the cratered highlands are older than that, probably closer to 4 billion years old. Then these lava plains are 3.8, 3.3, let's say. And then these craters that I called younger can be as young as a billion years and still look pretty fresh. I'm going to say that probably these guys are more like 500 million years old or something like that. The ones that I, for example, this one here with the ray pattern around it. We do know that there's some craters not visible at the moment, but will be in a few days' time, that are 100 million years old. So that on Earth is kind of in the late part of the Cretaceous, so the latter part of the era of dinosaurs on Earth. So, that's quite young. Now, we do know that things still smack into the moon, and so there are craters that are probably, of 1 or 2 years old. But most of what we're seeing here has been set in stone for at least 500 million years, if not 3 billion years. Ooh, I'm starting to shiver, so I've been out here for a while. Do catch my earlier broadcast that I inadvertently ended when I responded to a text. I thought I could multitask on this phone. What's the deepest crater? I don't know the answer to that. But I would say, some of these craters we're looking at, say in this area here, are probably in the 100 to 120 kilometer, 150 kilometer range. And initially when they formed, they were probably much smaller than that. The instantaneous cavity, when the thing kaboomed to create the crater, would have been maybe half of those diameters and about the same in radius depth. But those fill in pretty quickly. So I would be surprised, and I'm just now doing a wild ass guess, that anything deeper than about 10 or 15 kilometers would be exceptional. So these craters are, deep, no question about it, but they're not as deep as they are wide. And many of the simple little cup-like craters that we see, the small ones, which are what are called simple craters, they don't have a central rebound peak. Like these two craters here have a central rebound peak that we see. So the rock is so fractured that in a way it almost flows like a liquid. And when you imagine dropping water drops into a bathtub, you'll see that rebound. Well, that's what those central mountains are in those craters. The rock is so fractured, it almost flows like a fluid on the time scales of a few seconds. And then, because the rock is so fractured, the crater walls are also unstable. And over time, and now this can be days or weeks or even thousands of years, the crater walls collapse and we get terraces stepping down into them. So they slump inwards. And that causes the crater to expand laterally as the crater wall, what used to be outside the crater, slumps down and now becomes part of the interior. I'm going to try to zoom in a little bit on those guys there. And hopefully in moments of steady seeing, you can tell that there are steps. Those three craters, these guys right here, each of them will have terraces on their interior walls, and they would have all expanded and grown over time in the span of time after the initial impact. Whereas these smaller guys, I'll highlight this, that little guy there, that's just a simple cup. And the transition between simple craters and the more complex ones happens at about 10 kilometers across or about 15 kilometers. It's not a sharp cutoff. But if you're smaller than that, the crater was almost invariably just a simple cup. And larger than that, we tend to get these central rebound peaks. We get the terraces on the walls as the walls of the crater collapse. And with bigger ones, and I'm going to try to show that here. So this here has outer scarps and terraces out here. So when you have a big enough impact like what happened here, it causes the whole area to vibrate and shock, and we get these effects beyond the initial impact. So these are seismic shock waves that modify the area around the crater. And that happens with the really big ones. And sometimes you'll see multiple examples of these rings. But again, here's that scarp, that mountain range that's related to the impact that occurred here. So I think I'm going to go about 5 more minutes here because my nose is starting to run. My feet are getting cold. I'm definitely shivering. It's not super cold here, but the thing about doing astronomy is that you got to dress for temperatures that are 15 degrees Celsius colder than what the thermometer says. Because normally when you're out as an active Canadian in the winter, you're at least walking around in the wintertime and you're building up your own internal heat. Astronomy, you're basically just standing still. It's not an aerobic event. And because of that, your body's not warming up very much at all. So you need to dress for 15 degrees colder than what the actual temperature is read on the thermometer. I'm going to zoom out a little bit because the atmospheric stability. Oh yeah, photography is the same. Touching cold metal is the kiss of death, isn't it? If you're adjusting, luckily this telescope is a cardboard tube. It's got a wooden rim at the front where I'm holding it and a wooden framework down the tube. So it's not sucking the heat out of me. So it's pretty nice that way. But when I use one of my other telescopes that's metal, yeah, touching that metal when it's this cold is really bad. So here's the Sea of Tranquility. And I want you to notice the slightly bluish tone to the lava plain there. It's a different color than the lava plains around it. Just a very subtle, but that's the titanium content in the lavas is a little bit different. Hopefully you can see that. It's one of these lava plains. These are all basalts. Pretty dark rock, actually. In fact, the average reflectivity of the moon is something like the fresh asphalt on a road. That's how much light it reflects. About 7% of the sunlight that falls on the moon reflects back to us. Seems surprising for something that's so clearly obvious in the night sky. Yeah, but only 7% of the light falling on the moon shines back. The Earth albedo, or reflectivity, is much higher. And because of that, we have situations where the Earth is being illuminated by the sun that reflects off the Earth back to the moon. And the part of the moon that's in shadow here is actually illuminated. And I'm not sure if I zoom out, if we can see that effect yet, if the sky is dark enough. I'm just getting the hint that maybe with my unaided eye that we can see the rest of the moon's disk. So yes, I just barely can see the edge of the moon there. So the fact that I can barely just tell, we just wait a second we'll wait a few minutes then. That's the Earthshine. That's Earth, sunlight reflected off the Earth, illuminating the dark portion of the moon here. So you can just maybe detect that the circle is completed once that fades. It will become more obvious as it gets darker. Zoom in a little bit here and hopefully, yes, the camera has figured out what exposure to go with. It's a beautiful night, and if it wasn't so cool, I would probably spend a bit more time broadcasting. I'm just taking a look up at the moon now. Up to its upper left tonight is the planet Mars. And of course, NASA is gearing up for quite an event that's going to be starting broadcasting just before our local noon here in Alberta. So if you're listening in on this broadcast from other areas, you'll have to make your own offsets for time zones. But Perseverance is going to be landing early afternoon time here in Alberta, Mountain Standard Time. The so-called 7 minutes of terror, which is good NASA branding and hype for pretty spectacular pre-programmed maneuvers involving rockets and things like that, and just quite a involved way to land on Mars. And all that's necessary because, well, one, Perseverance is a pretty big piece of equipment, so it's pretty heavy. And secondly, the atmosphere on Mars is very thin. And so you can't just use a parachute and hope to slow things down enough that you get a safe landing. Of course, a few days ago, we had the United Arab Emirates put an orbiter in orbit around Mars. And then prior to that, China put their orbiter in. And of course, China's mission involves launching a rover as well. They are going to wait, I think, a couple months or so, maybe a bit more than that, before they detach their rover and send it to the surface. The NASA mission, of course, also will be landing a helicopter designed to hopefully fly in ultra-thin atmosphere. So that's pretty cool. That'll give them a different perspective on things. Be able to scout out places to go and perhaps more importantly, places not to go with their rover. All of those 3 missions launched about 7 months ago. It takes that long to get things out to Mars. And you want a particular alignment such that it's an easy pathway to get to Mars. And so you kind of wait while the Earth and Mars are lined up in a particular fashion so that after a 7-month travel, you're basically able to park your object either on the surface or in orbit around the planet. Tomorrow, I probably won't be out broadcasting because tomorrow we are hosting with our partners, the Calgary Public Library, an amazing talk on the atmosphere of Titan, presented by Ashley Walker. You might know her as that_astro_chick on Twitter, co-creator of the Black in Astro hashtag on Twitter. She's going to be talking about Titan, the giant moon of Saturn, and its atmosphere, and some of the modeling they've done here on Earth to kind of understand this nitrogen-rich atmosphere on Titan. So we've been pushing that on our Twitter channel, so just go back on our timeline and see that if you're interested in that. But tomorrow, if I were to do a broadcast, we'd be seeing Mars directly above the moon, very, very close. Tonight, they're, what do I want to say, about 12, 13 degrees away from each other. I can just see Mars now. It's up and to the left of the moon, a long ways, not a view I can encompass in this telescope. In fact, that's bigger span between Mars and the moon tonight than what you would get even in binoculars. Roughly 3 times the typical field of a binocular. So that gives you an idea. If you're going to go outside and look for Mars, that's where it is relative to the moon. Tomorrow night, because the moon moves roughly about 12 degrees eastward from one day to the next, or one night to the next, we'll see the moon and Mars much closer to each other. Oh, I just love the view. Kind of not a bad broadcast here, but I am definitely cooling off, and I think I'm going to end the broadcast. Thank you all for joining, and take care, everyone.